Welcome to machine learning. A wind turbine is a machine that converts the wind's kinetic energy into rotary mechanical energy, which is then used to do work. In more advanced models, the rotational energy is converted into electricity, the most versatile form of energy, by using a generator. A wind turbine consists of three basic parts: the tower, the nacelle, and the rotor blades. The tower is either a steel lattice tower similar to electrical towers or a steel tubular tower with an inside ladder to the nacelle. Most towers do not have guys, which are cables used for support, and most are made of steel that has been coated with a zinc alloy for protection, though some are painted instead. The tower of a typical American-made turbine is approximately 80 feet tall and weighs about 19,000 pounds. The nacelle is a strong, hollow shell that contains the inner workings of the wind turbine. Usually made of fiberglass, the nacelle contains the main drive shaft and the gearbox. It also contains the blade pitch control, a hydraulic system that controls the angle of the blades, and the yaw drive, which controls the position of the turbine relative to the wind. The generator and electronic controls are standard equipment whose main components are steel and copper. A typical nacelle for a current turbine weighs approximately 22,000 pounds. The most diverse use of materials and the most experimentation with new materials occur with the blades. Although the most dominant material used for the blades in commercial wind turbines is fiberglass with a hollow core, other materials in use include lightweight woods and aluminum. Wooden blades are solid, but most blades consist of a skin surrounding a core that is either hollow or filled with a lightweight substance such as plastic foam or honeycomb, or balsa wood. A typical fiberglass blade is about 15 meters in length and weighs approximately 2,500 pounds. Wind turbines also include a utility box, which converts the wind energy into electricity and which is located at the base of the tower. Various cables connect the utility box to the nacelle, while others connect the whole turbine to nearby turbines and to a transformer. Before consideration can be given to the construction of individual wind turbines, manufacturers must determine a proper area for the siting of wind farms. Winds must be consistent, and their speed must be regularly over 15.5 miles per hour, 25 kilometers per hour. If the winds are stronger during certain seasons, it is preferred that they be greatest during periods of maximum electricity use. In California's Altamont Pass, for instance, site of the world's largest wind farm, wind speed peaks in the summer when demand is high. In some areas of New England where wind farms are being considered, winds are strongest in the winter, when the need for heating increases the consumption of electrical power. Wind farms work best in open areas of slightly rolling land surrounded by mountains. These areas are preferred because the wind turbines can be placed on ridges and remain unobstructed by trees and buildings, and the mountains concentrate the airflow, creating a natural wind tunnel of stronger, faster winds. Wind farms must also be placed near utility lines to facilitate the transfer of the electricity to the local power plant. For thousands of years, people have used windmills to pump water or grind grain. Even into the 20th century, tall, slender, multi-vanned wind turbines made entirely of metal were used in American homes and ranches to pump water into the house's plumbing system or into the cattle's watering trough. After World War I, work was begun to develop wind turbines that could produce electricity. Marcellus Jacobs invented a prototype in 1927 that could provide power for a radio and a few lamps but little else. When demand for electricity increased later, Jacobs's small, inadequate wind turbines fell out of use. 4 aluminum blades are created by bolting sheets of aluminum together, while wooden blades are carved to form an aerodynamic propeller similar in cross-section to an airplane wing. 5, by far the greatest number of blades, however, are formed from fiberglass. The manufacture of fiberglass is a painstaking operation. First, a mold that is in 2 halves like a clamshell, yet shaped like a blade, is prepared. Next, a fiberglass resin composite mixture is applied to the inner surfaces of the mold, which is then closed. The fiberglass mixture must then dry for several hours. While it does, an air-filled bladder within the mold helps the blade keep its shape. After the fiberglass is dry, the mold is then opened and the bladder is removed. Final preparation of the blade involves cleaning, sanding, sealing the 2 halves, and painting. 6. The blades are usually bolted onto the nacelle after it has been placed onto the tower. Because assembly is easier to accomplish on the ground, Occasionally a three-pronged blade has two blades bolted onto the nacelle before it is lifted, and the third blade is bolted on after the nacelle is in place.